There's something curious about Scotland when seen from above. An almost perfectly straight line cuts right across the country from coast to coast. You might have never noticed, but that giant scar has existed for hundreds of millions of years. And right along its path lies one of Earth's biggest mysteries, the Loch Ness Monster. Meet the Great Glen Fault. Just like other major fault zones around the world, it was born because of the movement of Earth's tectonic plates. So let's go back in time, like 430 million years ago. At that point, a massive geological drama was going on called the Caledonian Orogeny. Now, orogeny is just a fancy scientific word for how mountains are formed. So this whole region looked totally different back then. There were these three ancient continents called Laurentia, Baltica, and Avalonia. Think of them like, giant puzzle pieces slowly floating around on Earth's surface. Over millions of years, these enormous chunks of land drifted and eventually smashed into each other. When they collided, the edges of the continents crumpled and folded, kind of like a piece of paper bunching up when you push it from both sides. But some scientists believe the continents didn't just crash straight into each other. Instead, they started sliding sideways past one another. Imagine pressing your fingertips together and rubbing your hands back and forth. That sideways motion is what scientists call a strike-slip fault. What I mean is, these massive blocks of rock move side to side rather than up and down. So, bit by bit, the land on either side of the fault kept inching past each other, shifting by several miles over geologic time. During the late Cretaceous to early Tertiary, which happened roughly 66 million years ago, the region shifted once again. This time, scientists believe the land's displacement was about 64 miles. Then, the ice ages came along. Rivers and glaciers found that giant crack in the earth and dug it out even more, making it deeper and wider. That's how they carved out the lakes that follow the fault's path. Finally, dump all of that into a geological blender, and there you have it, the Great Glen Fault in all of its majestic glory today. Yep, all that movement of the land helped sculpt the mountains and deep valleys that shape the highlands as we see now. Now the interesting thing is, the story of the Great Glen Fault doesn't stop in Scotland. This scar in Earth's crust actually has a secret twin across the ocean. The fault probably continues on the other side of the North Atlantic, over in North America. But over there, it's no longer one continuous crack. About 200 million years ago, Earth decided to shake things up. That's when the Mid-Atlantic Ridge began forming, basically a giant underwater mountain range that started pushing the continents apart and broke the original fault. So now, the North American side of the Great Glen Fault shows up as what is now called the Cabot Fault, also known as the Long Range Fault. It slices through the length of northwestern Newfoundland in Canada and even stretches out into the Gulf of St. Lawrence. Meanwhile, back in Scotland, the fault lines up perfectly with the Great Glen, a valley about 62 miles long, stretching from Inverness in the northeast all the way to Fort William. And it's filled with gorgeous lochs. One of the largest and most famous of these lochs, of course, is Loch Ness. Yes, I'm talking about the Loch Ness, that mysterious stretch of water that's said to be home to the Loch Ness Monster. You know, the legendary creature with the long neck that likes to poke out of the water every now and then, and that sends shivers down the spines of anyone lucky or unlucky enough to catch a glimpse. At least, that's what people say. But despite many years of searching for the creature, everything from thermal imaging drones to miniature submarines, no one has found any real evidence of the monster. And one interesting fact is that the Loch Ness Monster might be directly linked to the Great Glen Fault. Some geologists think that plenty of Nessie sightings might actually be, well, just simple bubbles, big ones, and they were probably caused by the fault itself. The thing is, all the movement in this region hasn't been confined to millions of years ago. Over the past 150 years or so, there have been occasional moderate earthquakes rumbling through the highlands. When the fault lines shift, even just a tiny bit, they can release gas pockets trapped underground. Then rising gas bubbles can disturb the surface of a lake, creating ripples, waves, or sudden bursts of movement across the water. And that's exactly the kind of thing that might look to someone standing on the shore like a giant creature swimming just beneath the surface. But in reality, it could simply be the Earth shifting by a fraction of an inch along that ancient fault. Or, as I like to put it, the lake has farted. Big question, is this region still moving? I mean, is this big geological map actually getting bigger nowadays? Well, it's hard to say, because scientists don't all agree. Some researchers think the Great Glen Fault is still active today. They consider it a reactivated strike-slip fault, meaning there might still be some action happening deep underground. The rocks on either side might still be straining and inching past each other. And in fact, occasional moderate tremors have been recorded over the past 150 years, usually with magnitudes of around 3 or 4. But not everyone is convinced. Other scientists point out that there is no solid evidence of significant modern activity along the main fault, and the seismic activity over the past few centuries hasn't been strong enough to prove the fault is seriously on the move. Take the Inverness earthquake that happened in 1901, for instance. To this day, it's considered one of the strongest that ever happened in Scotland. People felt it all across the country, and the earthquake damaged several buildings in Inverness. The situation was so intense that it gave the feeling of, oh boy, this crack is definitely growing. But the specialists aren't so convinced. Some believe it likely happened on a secondary fault connected to the Great Glen Fault, but not directly on the main fault itself. So, once again, it's hard to say for sure whether the Great Glen Fault is still actively moving today. Despite all the different studies and debates over many years, there are only a few conclusions about this huge gap that everyone agrees on. The fault is unusually straight, it is super ancient, and it is extremely deep by any standards. That's not the only cool fact about Scotland's territory, though. Let's travel to the islands that lie off the northwest coast of the mainland, to the Isle of Skye. This place was once home to a wide variety of dinosaurs during the Middle Jurassic period. The thing is, finding dinosaur fossils from this time period is super rare, but the Isle of Skye is an exception. Specialists discovered that about 167 million years ago, give or take, dinosaurs were mingling on the muddy edges of a warm lagoon over there. As they gathered around this ancient watering hole, they left behind layers of overlapping footprints. Specialists first noticed these tracks in the early 1890s, but at the time, they concluded that the impressions were petrified burrows of ancient fish. But then, in 2019, a graduate student from the University of Edinburgh went there and figured, nah, these are definitely three-toed dinosaur footprints. And he was right. Over several years of fieldwork, he and his colleagues discovered more than 130 individual prints. The team believes that the tracks were left by megalosaurs. These were large dinosaurs, around 20 feet long, and they were serious meat-eaters. In fact, they sat right at the top of the local food chain during the Middle Jurassic. But at the time those footprints were made, these big boys probably weren't hunting prey. No, their tracks show that they were just walking around, wandering in different directions, probably hanging out near the water. And this spot is so special because it gives us a rare peek into what life was like in the Jurassic period.
A giant crack, more than 2,000 miles long, is splitting open across Africa. Roads, houses, even schools are getting torn apart. Now, scientists think they've finally figured out what's causing it. An enormous column of scorching hot rock called superplume, rising from deep inside the Earth. And it's slowly pushing the land apart inch by inch. This isn't a small shift, though. The continent is breaking in two, and the clue to what's going on could be hidden thousands of miles away in Hawaii. And why does the United States suddenly have a role in all of this? Hang on, we'll get there. First, it's important to know this isn't new information. Africa has been slowly splitting for about 25 million years. This is happening in a region called the East African Rift System. It stretches thousands of miles from Ethiopia down to Mozambique and is the largest active continental rift system on the planet. And by that, I mean places where the Earth's crust is being stretched and pulled apart, causing faults, earthquakes, and volcanic eruptions. Scary stuff to say the least. Back in 2018, for example, a massive crack appeared near a small town just west of Kenya's capital, Nairobi. In some spots, it was about 65 feet wide. That's almost the length of 2 school buses parked one after the other. The whole thing was terrifying. It happened fast and left a trail of destruction. Roads were cut off, farms torn apart. People were on edge as the ground opened up beneath their feet. And I mean that quite literally. One man watched the crack rip straight through his home. He barely had time to grab a few of his belongings before his entire house collapsed. Sounds terrifying, right? Since it happened in the East African Rift region, panic spread fast. The media was all over it, claiming it was proof that Africa is splitting apart. People standing near the crack thought, oh boy, it's already happening. And many still believe that today. But that's not actually the case. At least not with that particular crack. Because after the initial panic, videos and photos of it revealed clues that it wasn't related to tectonic plate movement. First clue, the 2 sides of the crack didn't match. Like trying to fit the wrong puzzle pieces together. They simply didn't line up. Second clue, the gap wasn't one continuous line. There was some kind of soiled bridges in between. All this showed it was sudden erosion. I mean, some specialists believe the crack had once been filled with volcanic ash from nearby Mount Longonot. But then the region was hit with heavy rains. When water soaked through the soil, it washed the ash away, leaving the gap exposed. Problem solved. Even after the truth came out, it was too late. This event brought the whole Africa is splitting talk back. And here's the thing. Even though that crack had nothing to do with it, make no mistake, Africa is breaking apart. That's because the continent sits between 2 tectonic plates, the Somali plate in the east and the Nubian plate in the west. The problem is they're moving away from each other, and as they drift apart, the gap in the East African Rift keeps getting wider. Eventually, the Somali plate could split completely from the Nubian plate, creating an entirely new landmass, something on the scale of Madagascar or even New Zealand. You don't have to worry though. This process is super slow. So slow that none of us will see it finished. Experts say the continent is moving apart by about 0.3 inches a year in some places. To give you an idea, that's less than the length of your fingernail. So we can say this split will take millions of years, which is good news for the people living there. But that doesn't mean they won't feel the effects of this slow break. In fact, they're already happening. Take Ethiopia's Afar region, for example. Back in 2005, this area showed just how unpredictable the rift can be. In a short period, 420 earthquakes hit the area, opening up a massive fissure. What usually takes centuries happened in just a few days, completely challenging what scientists thought they knew about the speed of geological changes. Back then, the crack stretched for more than 35 miles, and life around it is still far from easy. Recent earthquakes destroyed much of the local infrastructure. 37 schools were damaged, leaving 5,000 students without classrooms. And that was just one part of the damage. As the tectonic plates keep moving apart, water will eventually flood into this region, creating a brand new ocean, according to some predictions. Countries like Zambia and Uganda, which are landlocked today, could one day have a coastline. That could be great news for them, as it might open up new trade routes and completely reshape their economies. Don't get too excited though. We won't be diving into the waters of this 6th ocean anytime soon. The splitting process will take another 5 to 10 million years. But it's tough to say exactly when, since big seismic events, like earthquakes, could make it all happen faster. So here's what we know. The Somali plate and the Nubian plate are in the middle of a dramatic tectonic breakup, slowly moving apart. Africa is breaking in two. Earth will probably gain a new ocean because of it. But until recently, we didn't know exactly what was triggering all of this. Like, yeah, those tectonic plates are moving, but why? I mean, is this massive geological process being driven by something happening in Earth's mantle? Or could it have a much larger, deeper source? Well, scientists think they may have finally cracked the mystery. They believe the continent is breaking apart because there's a deep mantle superplume, a huge column of hot rock beneath the East African Rift system. Think of it as a massive subterranean hammer pushing upward, pressing against the crust, and slowly cracking it apart. But here's the interesting thing. Scientists reached that conclusion thanks to something that happened in a completely different part of the world, Hawaii. Under this US state, there's also a plume of super hot rock rising from deep inside the planet. It melts the crust above it, and that's what fuels Hawaii's volcanoes. As the Pacific Plate drifts over this plume, molten rock breaks through in new spots, creating volcano after volcano. Over millions of years, that's how the Hawaiian Islands were formed. This Hawaiian plume contains noble gases like helium and neon. And you know where else scientists found those same gases? That's right, beneath the East African Rift system. Bingo! That discovery backed up the theory that a superplume is driving what's happening in Africa. And we call it super because it might be massive. You see, these same gases have been found in volcanic rocks from Kenya all the way down to Malawi. So everything points to the existence of a single superplume that stretches from the Indian Ocean to the Red Sea, not a bunch of several isolated sources. If their data and research are correct, scientists estimate that this superplume beneath Africa likely starts at the core mantle boundary, which is located about 1,800 miles deep inside the Earth. While the East African Rift system's chemical signatures are similar to those found in volcanic rocks in Hawaii, they're not identical. The Hawaiian plume is thought to be a narrow, rising stream of hot mantle, a bit like the movement inside a lava lamp. Africa's plume might be shaped differently, more like a large mass of hot, buoyant material rising from deep within the Earth. As it reaches the surface, this hot material hits the colder, solid outer layer and spreads out, pushing hard enough to crack it open and trigger intense volcanic activity across the region. And if this theory is right, we're watching a slow but unstoppable force that will redraw Africa's map and change the continent forever.
India could split horizontally into two parts as it runs into Eurasia. The movement of the Indian plate that includes most of modern South Asia is causing the Himalayas to grow. This process started around 60 million years ago when the plate first bumped into Eurasia. Scientists from the Netherlands have used the power of an AI simulator to see what this region will look like one day. The computer model showed that the Indian subcontinent will merge with the Horn of Africa in approximately 200 million years. The present-day cities of Mumbai and Mogadishu will become next-door neighbors. They will sit along the newly formed mountain chain scientists provisionally named the Somalaya. On the other side of this geological formation, Madagascar will connect with Sumatra, while Calcutta and the island of Mauritius will occupy the same region. Sri Lanka would cease to exist as it becomes part of the Indian mainland. Further to the north, scientists predict that the Himalayas are going to increase in height in the foreseeable future. As the Indian plate continues to mile northward, there will be major changes to the surrounding landscape. The present fault line will drift further south. Tens of thousands of years in the future, there might be no Nepal. The Himalayan range will have expanded sideways to fully engulf the mountainous country. And there may be way more earthquakes in this part of the world because of this movement. Most researchers agree the speed at which India is moving northward into Eurasia is barely 1/10 of an inch every year. Some of them think this is happening because of the plate's buoyancy. It prevents the Indian plate from sinking into the mantle, which gives Tibet its elevated topography. Other scholars believe that the structure is buckling under the pressure. The process resembles what happens to a sheet of paper when you push it horizontally against a wall. As you apply more pressure to its edge, the sheet starts to rise in the middle. In the real world, this bulge would be the Tibetan Plateau. A recent theory gives us the third explanation for the process. Their paper still has to undergo peer review, but the findings are intriguing. The international team of researchers introduced a new concept. the delamination of the Indian plate. This term simply means the separation of layers in a material that is supposed to be bonded together. Think of a sandwich that has cheese and ham slices between two buns. Take one of those layers out of the sandwich and you get delamination. In geological terms, this process involves the upper part of the plate peeling off and moving upwards. In the case of the Indian plate, this is the section that supports Tibet's elevation. The lower section is denser, which causes it to sink into the mantle. Plate tectonics are, in this way, similar to a layered cake. Chefs place the spongy, denser layer at the bottom, so the heavier top doesn't crush it. Scientists developed their thesis by analyzing helium gases in water samples from the region's hot springs. Helium-3 is a rare isotope that shows that the mantle is close to the surface of the Earth. Researchers measured helium isotope ratios at 200 Tibetan springs. The pattern they saw shows how close the mantle is to the northern Tibetan surface. Further to the south, they found plenty of helium-4, another isotope, which means that the plate is intact. It forms a barrier that helium-3 cannot penetrate, except in one region near Bhutan, in the eastern part of the Himalayas. The seismic activity in the region is good proof that delamination, the sandwich theory, is all real here. And it shows us that the mantle is intruding from the eastern side of the plateau. This concept puts under question the old, established ideas about tectonic plate behavior. The scientists behind the study suspect that the unique shape of the Indian plate contributes to the delamination process. It's the thickest at the northernmost point and the thinnest on the sides. If it's all true, it will mean that the continental collisions have a more dynamic and complex nature than geologists previously believed. Scientists still don't have enough hard evidence to prove the correctness of the new theory, just hints. Drilling to depths of over 60 miles is mechanically impossible right now. Such excavations are necessary to be 100% sure that the delamination process is going on. With the right technology, we would be able to better understand the hazards associated with earthquakes in the Asia-Pacific region. It's home to the famous Ring of Fire, where 75% of Earth's volcanoes are located. 9 out of 10 all earthquakes take place here. The India-Australia-Capricorn tectonic plate beneath the Indian Ocean is also important for solving Earth's tectonic mysteries. The term geophysicists use for such locations is nascent plate boundary. These are plates where tectonic plates are just starting to pull apart or push against each other. They represent the initial stage of a full-fledged plate boundary. Such a geological transformation unfolds at a pace of barely 5% of a single inch per year. That's about as long as a strand of spaghetti is wide. This shouldn't worry us too much from today's perspective. The India-Australia-Capricorn plate is destined to split in half over the course of tens of millions of years. Scientists from France studied records of 2 earthquakes that happened in 2012 and concluded there must be a nascent boundary there. Earthquakes normally occur at places where 2 or more tectonic plates meet. But the tremors in the Indian Ocean happened in the middle of the plate. The scientists used sonar scanning to map out the sea floor and see what was really going on there. After further examination of the marine area off the coast of Western Australia, researchers found a complex network of 62 pull-apart basins along a fracture zone. The scientific data backed up the idea that the tectonic plate was slowly but surely breaking apart. It's another proof that the outer layer of our planet is dynamic, not static. In some cases, you don't have to be a scientist to notice these powerful underground forces. Massive crevices emerged almost overnight due to heavy rainfall in a seismically active region in rural Kenya. First in 2018 and then again in 2023. The local population named the biggest of them the Grand Canyon. These events were not one-time incidents, but signals from the East African Rift System, part of the Great Rift Valley. This huge geological phenomenon stretching from Jordan to Mozambique shows us the gradual splitting of the African continent into 2 subcontinents. You can find rift valleys all around the world as proof of how tectonic plate movements are changing the planet. The East African Rift shows the underlying dynamics of the Nubian and Somali plates. The Nubian plate bears most of Africa, and the smaller Somali plate cradles the Horn of Africa. The two are gradually moving away from one another, which causes the formation of crevices within the rift valley. This process of continental rifting, going on at a rate slightly faster than the one in India, will eventually lead to the split of Africa into two continents. The whole process, which is about to happen in the next 10 to 50 million years, marks a significant geological event that reminds us of Earth's historical transformations. The last time our planet's geography changed so drastically was during the Jurassic period. The world map from the period looks recognizable, but the landmasses were oddly positioned from the modern perspective. In the north, Eurasia was still loosely connected to North America, which was at the time called Laurasia. This landmass was slowly moving away from the supercontinent of Gondwana, further down south. It consisted of what we know today as Africa, South America, Australia, and Antarctica. At the time, the Indian plate was closer to Madagascar than to Eurasia, as it is today.
That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.